So, how does ChatGPT work? In this presentation, we will consider the following questions. What is ChatGPT? What is the GPT architecture? How does a transformer-based neural network work? How are parameters distributed across layers? And how GPT chat is trained? First of all, ChatGPT is a large language model which is based on authentic GPT architecture. What is a large language model? Large language model is a neural network which is trained on massive amount of text data to understand and generate natural language. It uses so-called transformer-based neural network, about which we will say a few words, which excels at capturing context across long text sequences. So basically, a large language model, in particular ChatGPT, is trained to predict the next word in a sequence, allowing to generate coherent responses. For example, if I want to ask a question, Lionel Messi plays and the name of some sport, ChatGPT will generate the appropriate answer. So let us consider how it works and a few basic definitions. What is GPT? GPT means generative pre-trained transformer. So generative because it generates responses, pre-trained because it is preliminary trained only once in a few years by its developers, and transformer means some kind of neural network which processes very efficiently sequences of data like text. So the core components of GPT are so-called self-attention, which helps the model to understand relationships between different words in the sentence. Also feed-forward neural network, FFN, and also a number of layers, the principle of layer stacking, which we will consider in the next slide. Yes, GPT architecture consists of several layers. Each of them contains a self-attention mechanism and a feed-forward neural network. So how many layers are in GPT? In GPT-1 there were 12 layers, in GPT-2 up to 48, and GPT-3 for 96 layers, and GPT-4 even more, and GPT-3 already contained 175 billions of parameters, and it's about 2 billions of parameters in GPT-4. So, transformer. What is a transformer? Transformer is a deep learning architecture introduced in 2017 for processing sequential data, such as text. Its key components is the mechanism of self-attention. Attention, basically the name of the article which appeared in 2007 was "Attention is Everything." Attention is everything, both in spiritual and material life, and the self-attention mechanism in transformers allows the model to focus on different relevant parts of the input sequence of the sentence, not just word by word, but all the words in the sentence are taken into account and their proper context is understood for the subsequent processing. And also, feed-forward neural network, FFN, also helps to refine the obtained information by transformer. Transformer has many advantages, so it processes, as we already said, entire sequences in parallel, unlike recurrent neural networks, and it can capture a long-range dependencies very efficiently. It is used both in GPT and BERT for different tasks like translation, summarization, and text generation. So each transformer layer has two main components: self-attention itself and feed-forward neural network. And also they are surrounded by different additional auxiliary residual connections and layer normalizations for the proper training of these blocks. So how self-attention blocks, for example, in this case, we have a sentence: he is watching a French show. Yes, self-attention mechanism allows to understand that the principle is that someone is watching a show. A high attention is dedicated to this connection. That the fact that someone is watching a French show is not so important as, for example, as he's watching a show in this particular case. So Self-attention mechanism allows to understand the basic relationships between the words in a sentence according to the proper context. So why is it called self-attention, but not just attention? Because each token means a particular word in a sentence. Because each token pays attention to other tokens in the same sequence. And this enables the model to learn relationships and dependencies without relying on external context or sequences. That is why it's called self-attention. So, in each layer of transformer network, such as GPT, we have some input data, self-attention mechanism, then additional residual connections and normalization, then feed-forward neural network, which refines information obtained by the self-attention mechanism. Again, some additional preparation, some additional modifications, such as residual connections, and then the output to the next layer. And there are several tens, up to 100 of such layers inside the GPT network, inside GPT transformer. So each layer consists of many neurons. Each neuron is characterized by different weights and biases. Later we will have a slide explaining the structure of a basic neuron if you don't remember. And each layer has its own attention and feed-forward mechanism, and weights of the neuron determine how strongly tokens influence each other. And the first layers extract just superficial information, basic information, not superficial, but basic information, general information about the words in the sequence. And the following layers capture much more subtle and refined information, some nuances and minor details, which also can have some importance for the proper understanding. So, ChatGPT, how is it trained? It is trained on hundreds of gigabytes of text data. The sources of this data include books, articles, encyclopedias, websites, conversations, coding repositories, which is essential for programming. And this variety helps the model generalize across different domains. However, it doesn't contain real-time or private user data unless shared explicitly. So, as already said, each neuron is characterized by some weights and bias B. Weights W, they characterize the importance of each word in a sequence, in this case. So, and these weights and biases, they should be calculated during the training. Each neuron of many millions and billions of neurons has its own weights and biases, set of weights and bias, and they should be calculated during the training. This is a huge work which requires a lot of machine resources and a lot of time to be performed. Okay. So, of course, training of each neural network requires some loss function, and cross-entropy loss function is used for this purpose as a standard loss function, cross-entropy loss function. It includes predicted probabilities of each token, and it evaluates predictions across the total mass of tokens. And the goal is to minimize this loss function. It means to minimize the difference between predicted and true probabilities. So, gradient descent is used to determine these weights and biases. Here, just equation for the weights, standard gradient descent, where each of the billions of weights of GPT network is updated using the equation of gradient descent. We have some learning rate, we have gradient of loss function by the particular weight. So it iteratively, after many iterations, it minimizes the loss function across the data set. And so we have weights and biases for each neuron inside the network. So the knowledge that Lionel Messi plays exactly football, but not basketball, maybe he also plays basketball, but he's especially good at football, it's information, it's not explicitly in a straightforward way encoded in the parameters of GPT network, but it is spread. It is encoded across the 175 billions of parameters of GPT-3 network, or almost 2 trillions of parameters of GPT-4 network. This information is spread across a vast majority of these parameters. So, just for the conclusions, we consider that ChatGPT is based on the GPT architecture, which uses transformers with self-attention and feed-forward layers. It is trained on a massive dataset using cross-entropy and gradient descent, and its parameters are distributed across transformer layers, capturing patterns and relationships in text. And so it can generate human-like text by predicting tokens based on the context. Thank you very much for your attention.